always in the past, but I had enough people who asked me to just record it, so I'm just going to record it.
I like to re-listen,
So, yeah. I don't always, because sometimes it's kind of all over the place, but it's all good. If people want to sift through it, that's cool. So, exciting times. We have our first test coming up tomorrow. So it'll be here in class. You get an hour, and you can have your sheet of notes that you can bring with you. I don't provide any like formulas or anything on the exam, so if there's any like formulas that you feel like you need to know, like means, standard deviations, any of that stuff, you're responsible for making sure all that stuff gets on there. All I do is I just give you the test, and it has questions like this, but obviously with space for you to work, and then you can put whatever you want on your note sheet. It just can only be one-sided, and then it can be written, it can be typed, however you want to bring it in. It can just be one sheet of paper.
Front and back?
One side only, so choose one, the front or the back, you get to pick, and then that's the main details. Any questions in general about the test, and then we'll go into some of the content? Just generally speaking, yeah.
I noticed that our 2, 3, and 2, 4 quiz that was due yesterday.
Yes.
That was on IQRs, right?
Yes.
The last video that you posted.
And yes, it was the. Well, I posted 2 videos.
Yeah.
Yeah.
So it's gonna be on today's quiz, the 2, 5, and 2, 7.
That's a nice little question. I don't know. Now that you mention it, the one for today, it's the. Oh, you know what I did again? I switched the order of the. Yeah, I switched the order of the present because your books. I switched the order of the presentation. Your book does the IQR and outlier stuff first, and then it does mean and standard deviation. So the one that's due today is all the stuff with means and standard deviation. I got it out of order, and I meant to switch those, and I forgot again. So it was in the videos I posted,
Okay.
but it's just you haven't been tested on them calculating standard deviation and stuff yet. Apparently, doesn't look like on the quizzes. That's the one that's due today. Is the one doing? Yeah. Yeah. Sorry about that. Other questions? General questions about the exam?
Still didn't drop the lowest exam score too, right?
I don't think that's the case, but I'd have to check my syllabus to be sure. Yeah.
Sorry, one more. On yesterday's quiz,
Mhm.
it asked about an outlier.
Mm-hmm.
So I did the IQR test for outliers.
Yeah.
And I got that 25 was an outlier, but
Yeah.
I got it wrong. So I don't know what I did wrong.
That was the IQR test for number, what was it, number 4 or something like that? Or?
Yeah, I think so.
Oh, whoops. Whatever, I can do it this way too. It was from this data set right here, right?
Mm-hmm.
Yeah. So what were your numbers for that one? Because for this one, so if we do this, right? So what Q1 came out to be what? Was it 7? And Q3 came out to be 17. So the IQR is just the difference between those. So that's 10. To get your lower bound, you always go from. So this was in the videos I posted, but you always go from Q1 down 1.5 IQRs, and so we should go from 7 down 1.5 times 10. So that would take you actually down to like a negative number or something. So there's not going to be any negative outliers on the lower side. But to do the upper, and I think that's where this comes in. So the upper bound, you always go from Q3 up 1.5 IQRs, and that's just the rule. Those are just formulas, right? So the lower bound is always Q1 minus 1.5 IQRs. The upper bound is always Q3 plus 1.5 IQRs. So then from Q3, you would go 17 plus 1.5 times 10. And so that should take you up to, I think, 32. And I think that's...
Oh, okay, I think I did the Q1 and the Q3 on that.
Yeah, a lot of times it's just people will accidentally sub in like Q1 or the median or something here. but it's from Q3. So whatever that number was, you go from there. So then your upper bound is 32. So basically what the test says is based on the data in the IQR, we would expect to see data anywhere from like -8, which is really 0 because they're all positive, anywhere from like 0 to 32. And all of our data is in that range, so then you wouldn't really flag anything as an outlier. But that's, yeah, so that's just, those are just formulas, right? So the IQR is always Q3 minus Q1, and then the lower bound is always Q1 minus 1.5 IQRs, and the upper bound is always Q3 plus 1.5 IQRs. And those three formulas.
Can you imagine 25 credits at once?
25?
At once, credits at once. That's
Yeah,
crazy.
yeah. You see it on a lot. You do see it in some programs. A lot of lab hours.
Really?
Yeah. So some of our more like applied programs, they sometimes have 23, 25 credit quarters. But okay. So there's another one of those on the practice test too. So typically on review days, I just go through and I just let you guys tell me if there's any particular problems you want to see. Sometimes we get through everything. Sometimes we don't have enough time. So I usually just ask you guys which ones you want to go to first, if there's ones that are more important for you to see. So from the practice test, were there ones that you definitely wanted to go through? And we'll go there. Yeah. This one?
Yeah, 7 and 8.
Okay. So, all right, so for 7, talking about different types of variables. So if you're observing CBC students, what is the deal with qualitative? Yeah, it's like non-numerical stuff, right? So those are the things like what? You know, things like, you know, gender or what? What'd you say?
Like students, like if they're student, they're CBC.
Yeah, it could be like their enrollment status, right? Student, non-student, or full-time, part-time, just like non-numerical stuff, right? It's like quantitative continuous. What types of things are continuous?
Age.
Yeah, things like age, anything that measures time. So we would typically consider age continuous. Yeah. Yeah, so how much they paid, like intuition.
Anything that can be fractioned, right?
Yeah, more or less. Or anything that we round to decimals, kind of, I don't know, yeah. Money, time, weight, things like that. So tuition costs, you could give me all sorts of examples. There's no right or wrong answer here. They just have to be the right type. Discrete, though, those are things you can only have like whole number values of. So that'd be like what?
Credits per class.
Yeah, like you could say number of classes or credits that they're enrolled in. Classes, credits, that would be a great example of discrete. I'm too thick here. What else? I don't know. Could be number of siblings. That would be discrete, things like that. Yeah? And the last one, it's not really, I didn't ask you to calculate anything here. Just wanted you to kind of think about this. And it has to do with the shape of distributions. So they were saying that they reported the mean household income of residents. And I think that's a potentially dishonest representation. And why do you think that's true?
Because it's susceptible to outliers.
Yeah, because we know that in general, income tends to have a skewed distribution, right? And so what happens is, you know, the median is the halfway point, right? Because the median splits the data, you know, 50% below and 50% above. But in a skewed distribution with outliers, what happens to the mean? Yeah, the mean is going to get pulled up by any outliers in the data set. And so then the mean is probably pulled up or artificially inflated by the skewness. So for a question like that, I would say, you know, probably because they're skewed distributions, then the mean may be inflated or larger. It's just not really accurate. But that's why. Okay. So, all right. Yeah? Okay. What else? Where else do you want to go? We got some 5-number summary stuff, standard deviation stuff.
Empirical rule.
What's that?
Can we do one on the empirical rule?
Yeah.
How
Oh.
to find the difference between the.
Yeah, did I not put one on here?
Oh, I don't
On the practice test? Oh, here you go. So, yeah, so number 5. Yeah, number 5 is a good example of empirical rule. And so, let's move it down here and give myself some space. So, let's go. Here you go. All right. So, for number 5, then I give you a normal distribution, basically. So, I say, okay, well, we know that the distribution of male heights, so they have this mean at 69. So, I know it's an empirical rule problem because I give you the normal distribution, I give you the mean, I give you the standard deviation. We're talking about percentages and some, boundaries. So I always just start by drawing it. So this thing should be centered right at 69. And then our tick marks will be standard deviations. So then if you go up one standard deviation, right, I'm going to use the 3 inches. So 69 plus 3, that would be 72, plus 3 would be 75, plus 3 would be 78. Then going down, 69 minus 3, minus 3, minus 3. Okay, so then that kind of gives you the basis for how you're going to sort this thing out. Then I give you some boundaries. So like the first one says, well, what percentage would be between 66 and 75? So it's actually like, it makes up like 3 chunks of the distribution. So it's like all of this stuff. Now, what do we know already for sure?
The 68, 95, 97.
Yeah, so we know that the rule, right, is that it's, or I'm sorry, it should be here, 68, 95, yeah, and then 99.7, yeah, it's 99.7. I don't know if I can write there or not, 99.7, but that's the rule. So how are we going to use it here, though, because it doesn't really fall exactly on any of those categories?
You subtract the difference.
Yeah. So one thing I know for sure, right, is if you just look in this area, I know that's 68%, right, because that's the middle. So that much I know, but I need to tack on this extra chunk right here. So we have to figure out, well, what is that extra chunk? Okay. So how do you figure that out? And we did do one kind of like this before, right? So if this is 68 and this is 95, all right, well then we have to go from 68 up to 95. So how much gets added in there? Yeah, there's 27% that I have to account for between this bar and that bar, but it's symmetric, so you cut it in half, and so that means there's got to be 13.5% right there. So that's 13.5% right there, and then another, it'd be 13.5% there as well. But we don't actually care about that one. We only have one side of it, so it's just going to be 68 plus 13.5, and that should be what? 81.5%. Is that the only way to get it? It's not the only way to get it. I mean, you could think of it as, I guess I don't need to spend too much time on it, but there's more than one. I mean, you could think of it as like this right here. This right here is half of 95, right? And so that would be, 47.5 or something? 47.5%, right? And then you know that this chunk right here is 34% because it's half of the 85. So you could add them up. I mean, whatever. It doesn't matter, right? It's like the other way. Here's how most people do it. I'm going to tell you how a lot of my students end up doing it, and you're welcome to do it this way. Is you can kind of cheat a little, sort of. It's not really cheating. It makes it less interesting from a problem-solving approach, but it probably makes it easier. Is that if you think about it, the way it splits up is like these two both have to be 34%, right? Because the middle half has 68. And then we just figured out what these have to be, right? This has to be 13.5, and this has to be 13.5, right? And then you can go out to here. Well, from there, you have to get out to 99.7. And so you have to cover 4.7% of your distribution. So you cut that in half, and you'll find out that this has to be 2.35%. and this has to be 2.35%. And then the outer tails, there's only 0.3% for both sides, so then this has to be, you cut it in half. Yeah, so you could just have a more detailed little cheat sheet thing, and then you just you look at what ranges yours cover, and then you just add them up. So like our last example, it was this chunk, and this chunk, so just go 34 plus 34 plus 13 and a half, and then that gives you the 81.5%, which would be the right answer. So you just figure it out. You figure out the percentages once, and then you apply it. So then we can solve our next problem pretty easily, right? Because where is 60 inches? Yeah, 60 inches is 3 standard deviations below, right? And we can see from our picture, I already solved for that. It's going to be 0.15%. So, it really just depends. It's like the 6895 997 is handy, so then you don't have to remember 3 numbers. But if you have room on your formula sheet or you're like ever looking it up on Google at home, it's like you can just pick this picture up and use it that way too. It's just probably easier to do it that way. Any questions on that one? Okay. What else? Where shall we go?
When we answer those, do you want them in percentages? I know when I took stats in high school, we would get the points, like if we didn't put on 10% below or...
Units aren't a huge thing for me, but it would be best, to report it in the unit. Because I asked for percentages, it would be ideal if you gave me percentages as the answer. Yeah.
Not full sentences, though.
Yeah, like we have
it depends. In a question like this, all I'm asking for is a percentage. And so I'd be fine with just the answers. In a question like this, a complete sentence would be appreciated. I have to understand what you're trying to tell me. Yeah. But if I'm just asking you for one individual thing, then I don't necessarily need a whole sentence for that. Okay. What else?
And for what can be used in the calculator, it's okay to use without having to write.
Yeah, so I gave you guys that information about how to take data and use like standard deviation, for example. You might also notice that in your calculator, if you keep scrolling down, it also gives you like min, max, Q1, Q3, median, right? It spits out all that stuff for you. You don't have to calculate it by hand. And so if you use your calculator to get some values, you don't have to show me the work. You just need to put your number down and then just tell me, like in parentheses, like found it on my calculator. So it's not a bad idea. The only thing is, it's like if you don't show me any work, you just don't get any partial credit. So just make sure that you put your data in right so that you give me the right answer. Because otherwise, I don't know, maybe you just made up a number and then did it in my calculator, and I don't know, right? So be sure that your data was put in right if you're going to use your calculator. Yeah. Just double check it, to make sure that it's reasonable and there weren't any mistakes. But so 3 here, you can use the formulas to do number 3, but it's really not the most efficient way. I don't even recommend it. I would just pull out my calculator and put those data points in the calculator and then just let my calculator tell me what the answers are. So, and even for 4, the IQR, the quartile stuff really isn't as hard to do by hand, but if you don't want to do it by hand, you don't have to. You could take those, it wasn't 10, it was actually 20 people. But I'm just bad at typing, apparently. But anyways, it was you could plug those in and do the same thing in your calculator if you want. But that's not too bad either to do something like that by hand. The only downside on the exam, I'll give you ordered data. So I'll make sure that the data is given to you in order so you don't have to order it yourself. Because that's just time consuming and dumb. Because a computer can do it in like a millisecond. So I'll give it to you in order. I didn't give you this one in order just because I didn't. I don't know why. But the tests will all be in order. Yeah.
If you were to put that data in, like out of order into your calculator, would it still?
Yeah. Yeah, your calculator doesn't care about order. It'll do the min, max, and the quartiles. It'll do it all without. It'll order it itself. Yeah. Mm-hmm. So, anybody want to see this one or any other ones? What do you say? This is stuff we didn't actually go over. This was stuff I posted out in the videos on Monday night. And so this is for doing, medians, IQRs, that kind of fun stuff. So I'll just pull it down into the next page and then give myself some. Oh wait, I already had a whole page going. All right. So for the 5-number summary, that's just the the min, max, and the quartiles. And we went over that though, I believe, right? Yeah. But you need it for the later stuff. So first off, what you'd have to do if I didn't give it to you in order, which I will. So it's 1, 2, 3, 5 zeros. You need to order this thing. What comes after that? What's next?
5.
A 5, then a 7, 2 8s, 10 comes next. 12, yeah, 14, 15, 11 in there. Yeah. What else we got now?
30, 35,
20,
120.
How about 20?
22.
20, 22. Then we hop up to 30, 35, and then 65.
And 40.
Oh, there's a 40 in there. Yeah, good call.
This is why it's going to be in order.
Yeah, this is why I give it to you in order, because it's just like so easy to mess up on that step, and it's really inconsequential because I'm confident if you paid enough attention, you could order data. But anyways, so if I'm going for, obviously, so the easiest ones are the min and the max. So I'll just make my list here. So when I say 5-number summary, these are the 5 numbers I'm talking about. It's the min, the first quartile, the median, and the max. The min and the max are the easiest because they're literally just the min and the max. The median we know how to get. So this data set happens to have 20 students in it. So there is not going to be a true median, right? It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to split our data set in half. So you have a lower half and an upper half. But in this case, since there is no true median, we're going to have to average those. And so you just add them up and divide by 2, or you just split the difference. It's going to be 10 and a half. Same thing happens when you split this data set into like the lower half and then the upper half. The lower half has 10 observations. So to get the lower quartile, you go 1, 2, 3, 4, 5. You split that in half. But again, there is no true median of the lower half, so you have to average those. Yeah, so it comes out to be 2.5. And then same upstairs, 1, 2, 3, 4, 5. There's no true median, so you have to average 20 and 22, and that gets you 21. Okay. So these are the 5 numbers of the 5-number summary. Okay. Any questions on how to calculate those? If it happens to be odd number data sets, then the median just exists, and that makes it easier. But if not, you have to do this. So then those are used for all of the rest of these. So again, the calculator is not bad too, because then you know you got the right values, and then if you carry those values on through the rest of the problem, it'll cause problems if you get them wrong at the outset. So you really want to make sure you get that on multi-part problems. You need to make sure you get those right on the outset. So then, to get the IQR, this is what I was showing you a minute ago. The IQR is always Q3 minus Q1. And so that would be 21 minus 2.5. What does that come out to be? 18.5? Excuse me. Okay. So that's not really that useful in and of itself. The way it's going to be most useful is for the next part. So if we want to try to test the data set for outliers, then the formula says, okay, we can establish a lower bound and an upper bound. The lower bound will go from Q1 down 1.5 IQRs. So these are the formulas. And to get the upper bound, we'll go from Q3 up 1.5 IQRs. So that's just the rule, basically. So then, Q1, we already calculated it. It was what, 2.5? Minus 1.5, and the IQR was 18.5. And so that's going to be 2.5 minus 1.5 times 18.5. 20, is it 25.25? Is that the answer, or is that 1.5 IQRs?
Wait, what?
I think that's the
That's
answer.
the answer.
That's the answer. What is it actually? If you do 1.5 times the 18.5, what do you get? Isn't it like 27.25? 27.75? There you go. And that's how you got the negative 25.25. So that's your lower bound. It's just saying, like, we would not expect to see any numbers below negative 25.25, which makes sense because none of our data goes negative. Then for the upper bound, so you go from Q3. So we're going to go up from 21, up 1.5 IQR. So basically, we're going to take that 27.75, and this time we're going to add it. So it's like that. And that would take you up to what, 48.75? Did I do that right? Okay. And so then the way it works, though, is then you go back to your data set and you just look, is there anything that's outside these bounds? That's what you ask. And so you say, is there anything below negative 25.25? No, there's not. But if you look, is there anything above 48.75? Yeah, and my data set 65 exceeds. So it turns out that 65 is actually here a potential outlier, whereas the one on the quiz didn't have a potential outlier, but that one would be a potential outlier. That one looks a little bit too high, a little bit suspicious. So. Okay? All right. Cool. And then when you're doing a box plot, so the way box plots work, that's not really good. So box plots are just a way to display the 5-number summary. And so you just have an axis down here, and then we've got, what is our stuff? Basically like 0 to 70, so maybe we'll go by 10, so it'll be 10, 20, 30, 40, 50, 60, 70. So you can make yourself a scale down there. The boxes go from Q1 to Q3. So you just say, okay, well, Q1 was 2.5, and Q3 was, what, 21? So our box will go from 2.5 to 21. Okay. Then you put a line at the median. So our median was 10.5. That's about right here. What was our min? Our min, so then the whiskers go out to the min, 0, and they go out to the max, 65. That's it. The box plot is just a quick way to show you the shape of a distribution. So this distribution is obviously skewed because the box plot is not symmetric. So if the box plot were symmetric, then it'd be symmetric. Yeah? Okay. Mm-hmm.
And then it's skewed to wherever the tail's going, right? So that would be like skewed right.
Skewed right.
Could you show this one as 65 being an outlier?
Excuse me. Something going on here. Yeah. There is another way to draw a box plot. If you identify outliers, what you'll see is you'll see them just, the box plot will only go up to the next closest non-outlier. So 40 wasn't an outlier, but 65 was considered a potential. So you'll see the whisker will only extend to 40, and then it'll have a star out there to show that there's a potential outlier out there in your data set. They're both reasonable ways to draw a box plot. I don't really care how you choose to draw it. Either one's fine. So sometimes it's kind of interesting to look at both because if 65 belongs in your distribution, it's a very skewed distribution. But if 65, if you go back and look at that observation, decide for whatever reason it doesn't really belong there, then you can see that the actual distribution is maybe actually not that skewed. It's maybe a little skewed, but not nearly as skewed. So, okay. All right.
How do we find the outliers again? Like,
Well, it's just once you get those boundaries, once you get these boundaries, see, so this is just a formula.
yeah, but like,
Mhm.
so when you say anything outside bonds, how do
Yeah.
we know?
So you're going back to your original data,
Mhm.
and you're looking for any number that goes below that or above that. We're going to flag it. If it's in between these two numbers, it's fine.
Oh.
You know, it's like anything in between there, it's like I would not be surprised to see data anywhere in that range. But if you go outside that range, then those are the numbers you're going to flag. But we only had one observation in our data set that went beyond that. It was the 65. And so that's what we would flag. Yeah. All right. What else? Anything else you want to take a look at here? What do you think? It doesn't have to be from here too. It could be from any of the other stuff that you take a look at.
If we are calculating the standard deviation, if we find it from a calculator, is that fine?
Yeah, that's what I was saying earlier. You can just write next to it. Just be like found from my calculator. Yeah. Mm-hmm.
How do you calculate standard deviation by hand?
You could do it. It's not too bad. Remember so the way that goes is that's where you start. You just do a table, right? And then you start by you have all of these entries, you know, and it's the one where so essentially what you have to do first is you have to get your mean, and then you have to go through and you have to subtract all the means, right? So you have to do that column, and then you have to square them all, you'll get that column, and then you go through and you add up like all these values, and that's that sum that then gets plugged into this formula. So if you go back and look at my examples, I went through one in the lecture this way. It's pretty time consuming though. So I don't particularly recommend doing it that way, and there's a lot of room for error. Yeah. Yeah, so so there's some tutorials in Canvas, but if you want to stick around at the end today, if we have time, I can try to walk you through one on your calculator too. But there's also in the calculator resources that I added in the modules, you can check that out, and it has an explanation for how to do. Hmm?
So if that you have a question asking you to do it handwritten on the test,
I wouldn't ask you to do it necessarily by hand. I'll ask you just to give me the standard deviation. And then however you find it is up to you. My recommendation is learn how to do it in the calculator because it's way more efficient and accurate. So and you have the TI-30, so the directions for that one specifically are on Canvas too. So
Can you share calculator?
no, you can't share calculators. Sorry. Someone asked about number 2.
Yeah, I did.
Okay, so this was it was a study to look at risk of developing preeclampsia, which is high blood pressure brought on by factors related to pregnancy. They randomly selected 300 women, and each woman did a food diary, and then they looked at their average daily sugar intake, and they recorded whether or not they developed symptoms of preeclampsia. That's what they were recording. And so would this be an example of an observational experiment or an observational study or an experiment? It's observational. How do you know it's observational?
Because they didn't introduce anything.
Yeah, they didn't really introduce anything. They're just asking them what they ate. You know, they're not really controlling their diet. If they went into if they could actually control it and they could feed them, you know, for their whole pregnancy, that would be an experiment, but that's not really possible. So it's an observational experiment. What does it appear the explanatory variable here is?
Average.
Yeah, it's the sugar intake, right? So the explanatory variable would be their average daily sugar intake, because that's apparently what they think is doing the explaining, or they're thinking it could be. And then what's the response?
Clam.
Yeah, it's just whether or not they developed preeclampsia. So,
If you ask us for lurking variables, it's basically our best assumption of what it could be? Because, I mean, there's a lot.
Yeah, as far as lurking variables go, I mean, you could give me a lot of answers, right? Because what are some of them?
It could be hereditary.
Yeah, it could be
race,
hereditary.
like predispositions.
Yeah, so it could be their health going into pregnancy. It could be all sorts. Do they smoke? Do they drink alcohol? Hopefully not while they're pregnant, but I don't know. You know, do they do other recreational drugs? Do they exercise? Do they, you know, all that other stuff? There's tons of lurking variables. So I'm just looking for some of them. Okay. All right. Population. What is it? What do you think the population is here?
Pregnant.
Pregnant women. Yeah, and it kind of, you know, normally the population is going to be listed somewhere. It says it right here, you know. It's right there. Pregnant women in the U.S. Sorry, not very good with my mouse, but you get it. That's the population. The sample, though, is just what?
This is like the 300.
Yes, it's the 300 they actually observed. So the population is like the big group they're probably interested in, and the sample is like the small group they actually, you know, observe data from. So, all right.
So our parameter in that one would be preeclampsia in pregnant women, correct? That would be the parameters, the whole thing, and then the sample.
Yeah, I didn't really give you any statistics or parameters here necessarily. The parameter could be the parameter is actually complicated here because it's just the presence of preeclampsia, either yes or no. So it's sort of a you could either think of it as it's like a qualitative variable almost. They either have it or they don't, or you could think of it as like a binary, like a discrete random variable where they can only either have it or not have it. So, yeah. And I didn't really give you any statistics here, or it could be a percentage or something. I don't know, but yeah. I didn't really ask for parameters or statistics here because it'd be hard to tease out exactly what they are in this case. So, anywho, what is it?
Can you
Yeah.
go over number 5B?
Uh huh.
5B5.
5. The one with the one with this one.
Yeah.
The one we did with the empirical rule? Yeah, so we were doing that one. Well, we already did that one, but I can just revisit. It's just the idea, you're just using the 68, 95, 997 rule. And because in a normal distribution, the data are always pretty much approximately distributed this way. So I just went through and just kind of gave you a little cheat sheet. You can use this. You can write this down on your exam. This is basically how it breaks apart. So all you have to do is draw your distribution, you know, like I did up here. You know, I drew my distribution, and then you just say, okay, well, which chunks of that normal distribution are we talking about? Oh, okay, well, in this case, below 60 inches is just that very bottom tail, and that's that 0.15%. Yeah. Okay. Yes. Yeah. So this one is a z-score problem. So you got two populations, and you're just trying to compare, you know, who's basically more exceptional in among their peers. And so you have the males, their mean is 69, standard deviation 3. Females, mean 64, standard deviation 2. So you got one person who's 74. So basically we're just going to do two z-scores here. And remember, a z-score is a measure of relative standing, and it measures how many standard deviations above or below average someone is. And so that's the formula. There's another formula you probably want to keep on your formula sheet. So for the guy, he's 74 inches tall, and he comes from a population with a mean of 69 and a standard deviation of 3. Whereas the girl, she's 69 inches tall, but she's coming from a population with an average of 64 inches and a standard deviation of 2. And so here, this guy right here, he is 5 inches above average, but is standard deviation 3 inches. And so that comes out to be like, what, 1.67, I think, if you round. And then this person right here, she is 5 inches above average from a population with standard deviation 2, but that z-score comes out to be 2.5, right? And so this person right here is much taller, but it's, you know, with respect to competition. because she's actually shorter than the guy, right? But she's much taller. She's 2.5 standard deviations above average, which is pretty exceptional. More than 2 standard deviations above average is pretty high. So she's probably pretty tall. So, yeah? All right. What? Anything else particular you wanted to ask or look at? Make sure you know how to use your calculators. That's good. And again, if you haven't looked at it yet, right? So in the modules, I put in module 2, I added it right under all of the slides and stuff. It's just calculator resources. So I gave it to you 2 ways. It just depends on which way you prefer. If you like the PDF that walks you through it, you can just download that and follow the steps, and it actually shows you the buttons to push. Or you can watch this guy right here do a very riveting YouTube video. But he also walks you can see his keystrokes too, which is kind of cool. And you can watch him enter data and find those summary statistics. And anyways, that's where you can get all that stuff at. Mean, standard deviation, 5-number summary. I think it even spits out the IQR. It might even, I think. It just throws out all those numbers that we use in these first couple modules. So check that out. And you can do it on other calculators, but I think this one's the best one for this class. That's my opinion. So, all right. Anything else you wanted to ask or look at? That's most of the tests. It'll be pretty similar to, this, or if you take a look at between the practice test and the extra practice worksheets I just threw into the exam module. So, I have these extra 3 down here. You could just maybe take a look at those as well. It's going to be most similar to those 4 documents. If you get through those and you're feeling pretty good and you just want to review some more, you could go back maybe through your quizzes, and just look back at the previous quiz problems. I think those would also be okay to look at. I'm not going to put anything on there crazy, though. It's not like anything you haven't seen yet. I don't know, actually. I can't remember, actually.
It's not multiple choice, right?
No, I did put a little bit of multiple choice at the beginning, but not much. There's just a couple multiple choice ones. Just like with all that stuff with like population and parameters, and some of that vocabulary stuff is in a multiple choice format, and then there's a lot more of it's just free response. But there's not like tons of problems, but some of them are multi-part.
And you didn't bring a sheet.
One sheet,
On the back of it or the back?
one side only. Yeah.
Next class.
Let me grab his nugget. Yeah.
So we're not turning in our practice test, right? Or-
No.
Okay.
No, I don't collect the practice tests. I don't collect your note sheets. Really, I mean, you can hand them to me, but I don't really. They're for you. Question?
Is there anything on the practice exam that's not on the test?
I don't know. I don't think.
Anything on the test that's not on like practice exam?
There could be, but I'm not trying to trick you or anything. I don't think so. Normally, I accidentally do it the other way. Normally, I'll forget to put things on the test that were on the practice test. I rarely do it the other way, or I try not to. But yeah, but I don't think between the practice test and these 3 practices, I think you will have seen everything that I'll probably ask you about. But technically, anything we covered in class is fair game. I can't put everything on the test, so. So if you want to stick around and ask questions, you can. If you feel like you're okay, then you can head on, and I'll see you tomorrow. And this is how I typically do review days. So
And we get the full class hour, right?
whole hour, yeah, you get the full class.
I try to do hand calculating. Oh my goodness, that takes forever.
Yeah, it's not ideal. It's not ideal. There's really no reason, honestly, to do it by hand. So
And then once we're done with the test, we can just...
yeah, and then once you're done, you're done.
Cool. That was always my least favorite thing in high school. You finish the test, and you just had to sit
You had to
there.
sit around.
Yeah.
Yeah,
Being an adult is awesome.
exactly.
Oh yeah, I have one morning class, 8
lecture recordings. So when you log into Canvas, just click on Panopto recordings.
Okay, and it just.
And then you can go back through. I record all my classes basically. So like, I'm still recording. I need to upload that. But here's today's. You can see